In this session, I'm going to work some problems in Chapter 4. Actually, in Chapter 4, there are only 5 problems in the problem set in the assignment. And I'm going to at least set up 3 of them. However, again, your problems may have different numbers and be in a different order than mine because of the randomization by the Connect system of McGraw-Hill. Another thing that I found was that the author said that problems 4 and 5 were linked. Now I'm going to work problem 5, but not problem 4. And if you read problem 5 by itself, it doesn't have an interest rate given. But what I did, what you have to do to get an answer, because you have to have an interest rate, is there was an interest rate given in problem 4 of the statement of the 2 problems, and so I had to use that interest rate to get the answer to problem 5. So if you ever hear that, or read, I'm sorry, that 2 problems are linked or they're part of a series and data is given in one, it may apply to the other. Most of the time when he does that, he repeats the data. So for example, in another part where he's using a problem, I think with 13% or something like that, he gives that data in both, I think in problems 1 and 2, in fact. And I'm not working 2, but I am working 1. He gives the 13% per year, but he states it also in problem 2. If he had omitted it, well, then you would have known that because 1 and 2 were linked to use 13% in problem 2. I think he should always repeat it, but in problem 5, he didn't. So I just wanted to alert you to that as well. Okay, so we're going to read this problem, set it up, and then I'll let you, work it out to get the answers. The problem says Yvonne's father was a true believer in giving back. He endowed usually when you hear the word endow, that means that you're setting up a scholarship or something like that, and you are going to it's going to produce income forever, okay? And so usually that should ring a bell. I may be dealing with a capitalized amount here. What the author used the symbol CC. To represent that, and we discussed it in chapter 4, whereas the CC was the present worth, basically, the capitalized amount is the present worth of a infinite uniform series. So let's read on. He endowed a program 35 years ago to help students receive degrees when they are short of funds. How much money was contributed 35 years ago if the fund earned a rate of 13% per year with no withdrawals? So we're putting here and we're saying how much was put in here, P equals question mark. And this happened 35 years ago, so this is year 35. During this period of time, the fund was earning at 13% per year, okay? Now, we'll read on, okay? Now it is sufficient to provide perpetual income, of $46,000 a year. That means forever, $46,000 a year, beginning this year in year 35. Okay, so this is the end of year 35. So we'll put the the amount that it's going to provide, which is 46,000, has got to start here. And that will go on. 36, and then 37, and on into forever and approaching infinity. Okay, so this is a uniform series, and I want to find its value. But it turns out that the capitalized equivalent will be a value right here, right? Because the present value of a series occurs 1 year before the first cash flow. So actually, it will be at year 34 if I find the capitalized value. So basically what I'm saying is the value, the present worth at time 34 of that series is equal to A, P given A, I, N, and that's as N goes to infinity. So really, it's just a capitalized worth. It's A divided by I. Remember that formula. So this is going to be a number then at year 34. And it's going to be 46,000. That's our annual. That's dollars per year. And then we're going to divide that by 0.13, which is the interest rate. Assuming you can earn interest rate from here all the way on into infinity. That you'd have to be a genius investor. Okay, so if we run through this example, then we'll get a value that's right here. Well, that's 34 years from back here. So this value, although it's a capitalized amount, it's also a future value relative to time 0. So what we need to do when we compute this value, by the way, it's equal to $353,000 and 846. Okay, 353,846. That's a value that is right here in time, but that's a future value relative to this point in time. So the present value at 13% will be equal to that future value, F, P given F, 13% for 34 periods. So we will take that 353,846 and multiply times 1.13 to the minus 34. And you'll get $5,548. Amazing. If you could earn that kind of interest, that $5,548 will produce an infinite A series of $46,000 a year, but you have to earn that huge interest rate. Not impossible, but you'd have to be a pretty darn good investor. The next problem that I'm going to look at is problem 4.3 when I accessed the homework assignment. And this says Navistar Electric issued 1,000 debentures or bonds, debenture bonds, 9 years ago. So those bonds were issued 9 years ago with a face value of $5,000. So let's just write that down first. V equal $5,000. Okay, they issued 1,000 of them, so they were trying to get $5 million roughly. The bond interest rate is 13% per year, payable semi-annually. So that says B, which is the annual interest rate on the bond, is 13%, that's per year, but it's payable semi-annually, so C, the number of times it's paid per year, is 2. And from this information, we can calculate what the bond dividend is using the formula I equals VB divided by C, which is 5,000 times 0.13 divided by 2, so that's 6.5% of $5,000. And so I got for that value $325, and that will be per semi-annual period. So this will be every 6 months you'll get $325 as long as the bond is still outstanding. And it says this when the bonds have a maturity date 20 years from the date they were issued. Now they were issued 9 years ago. So that's going to be 11 years from now, okay? If the interest rate in the market is 10% per year compounded semi-annually, what he's really saying is if that's a MAR that you're going to work with, so I'm going to just say that I is equal to 10% per year compounded semi-annually. Now I want the effective semi-annual rate because I have semi-annual dividend payments here. So if I remember the cash flow diagram for almost all bonds looks like this. You buy a bond for a certain price and you receive the dividends I, in this case these are $325 per 6 months or semi-annual. And this is going to go on for how long? Well, the bond is 9 years old. It's going to last for 20 years. So that's going to mean this is going to be 11 years. But it's every 6 months that you get these dividends. So this is the first one. This is the second one. That's 1 year across that whole time frame. So this is going to be 22 semi-annual periods. So you're going to get this $325 22 times. And then you'll get your $5,000 face value as well when the bond matures in 11 more years or 22 more semi-annual periods. And what we want to know is what is the value, the present worth of this bond, but we're going to use the rate of 10% per year compounded semi-annually. So what's the effective semi-annual rate? Well, remember the effective rate formula. I is equal to 1 plus R, this period, semi-annual, divided by M. That's the number of times it's compounded in a semi-annual period. Well, that's going to be 1. So to the M power. So we're going to end up with 1 plus 0.05. R semi-annual, if that's annual, then this is semi-annual, over 1 to the 1 minus 1 minus 1. This is going to be 5%. Okay, so all I'm going to do is use 5% semi-annual and get the present worth. So the present worth of the bond series at 5% is going to be $325. That's a uniform series. That's going to be times P given A, 5% for 22 of them, plus your face value, $5,000, P given F. 5% for 22, and that will give you the value. So when I did this, I got 59.87. The last problem that I'm going to look at is kind of a long-winded problem, but I'll read through it with you. It says a sports mortgage is the brainchild of Stadium Capital Financial Group, financing group, a company headquartered in Chicago. It is an innovative way to finance cash-strapped sports programs by allowing fans to sign up to pay a mortgage over a certain number of years for the right to buy good seats at football games for several decades with season ticket prices locked in, so no increases in prices. The locked-in price period is 50 years in California. Assume you and your brother went to UCLA. Your brother Harold purchased a $40,000 mortgage and pays for it now to get season tickets for $290 each for 50 years. While you, being a three-time alumnus of the same university, are able to buy season tickets for $390 in year one with price increases of $20 a year for 50 years. So every year they're going to go up by 20. You're going to pay $390 the first year. What should Harold have been willing to pay UCLA up front for the mortgage to make the two plans exactly equivalent economically? Assume Harold has no reason to give extra money to UCLA this point, and that the seats are the same level next to each other and so on. Now, when I read the problem, I didn't see any interest rate, so I said, wow, can't solve it. But back in problem 4, he gave an interest rate of, let's see, what was it? It's 8%. 8%. And he said these two problems were connected, so I'm going to use 8% to solve this problem. Now, what you have is basically, if you look at the pricing, the price with the mortgage, let's say price with mortgage, which is just basically, it's an upfront cost, is going to be $290 a year every year for 50 years. Okay. If you don't buy the mortgage, then your price is going to be, this will be without mortgage. You'll pay $390 the first year, and it's going to increase by $20 a year every year thereafter. So this would be $410 and so on, but that's we don't have to worry about. This is 50 years. So what we have is a uniform series here of 390 plus a gradient series, a G. Actually, it's minus 390. This is minus 290. The gradient is minus 20. Okay? So now we have to basically compare these two series and choose the best value. So I'm going to work the problem here, and so you can see the cash flows. I'm going to there's a couple of ways to work this problem. One is just to set the present worth of this equal to the present worth of this plus your mortgage. This you have to get the mortgage. Let's say this is MX, however, mortgage, which is just a present value. P equals mortgage. And this doesn't have it. So now we set the present worths of these two equal to one another. Present worth no, with mortgage, and then there'll be a present worth without. And they'll both be at 8%. And we'll set those equal to one another. Well, the present worth with the mortgage is, we'll just say, well, that's a present value. That's a minus X MX dollars. And this is minus 290 P given A, 8% for 50 years. Without the mortgage, you don't have any initial costs here. It's just a uniform series minus 390. That's the uniform series part. P given A, 8% for 5 years. Plus, you have this gradient, which is a minus 20. P given G, 8% for 50 years. And now you just set these two equal to one another, and you solve for the unknown MX, okay, or the mortgage amount. I'll let you go ahead and do that with this problem, and we'll end this homework session right here. Thank you.